So hi guys, how are you? Mm. So last time on the yesterday we have seen the cat dog classifier, right? So it is about theory, but today we are gonna see in a code. Well, we are gonna compare the images and we're gonna find the cat dog classification in a real time. So okay, one second. Actually, I'm fixing the code. I have used before 2 years. Now it is outdated, so I'm fixing the code. One sec. Okay. Anyhow, like I'll share. I'll tell you where the data is. So this is our data. So in this data, we do have two folders. One is train and another one is test. So like as I said, like machine learning will work like we need to feed the data in a training data set. So it will read all the data and it will pre-process everything and it will convert to a binary format where the machine can able to understand the images. So these are the images I have used to train our model. It consists of around I think there are 10,000 to 12,000 data for each. Like in cat I'm having 12,000 data and in dog I'm having 12,000 data. So these are total data, like 24,000 data. In you can see, like in trained data I'm having the name called cat, right? So this is what we call as a label. And then in test we don't have the label, we just have 1 2 3, and it is a mixture of both cats and dogs. So here you can see it is cat and this dog, so it is a mixture of cat and dog. So while we feed this data to our model, it will automatically find which are all cats and which are all dogs. So I'll show you in detail. Now you can hear me clearly, right? So
Yes.
Yes, perfect.
okay. So,
Yes.
okay.
Today is good, Imran.
Okay.
Yes, Imran, we can hear you.
So I'll tell you where. I'll tell you from where I get the data. So we do have a portal called Kaggle. So in this Kaggle, we can get all types of data sets. So it will consist all types of data set. Like it can be textual or it can be an image. So we can get all types of data in the Kaggle. So from here only I got the data. So it can, like you can see it is 853 MBs. So it consists all the data what I got, as well as it has all types of data. Like if I go to data set, you can see so it is updated, I think. So that's why yesterday Netflix is updated, so now it is Adani Group's companies stock data. So like as we can get all types of data here. So from here I got the data set. So and then I'm gonna use TensorFlow. So I'll tell you what is TensorFlow first. So TensorFlow is a framework. What we are gonna use it to perform deep learning. So TensorFlow has been like built by Google. So we do have another package, like alternative package to TensorFlow called PyTorch. It is built by Facebook, but today we're gonna use TensorFlow. It is built by Google. So TensorFlow will use a backend, the name called Keras. So in Keras only we do have all the models we want. So using Keras, the TensorFlow is creating a model. So I'll show you the code one by one. So first I'm gonna import, like if you are familiar with Python means you can understand, or else I'll tell you. So this is where I'm importing all the required packages. So I'm using NumPy, Pandas, and then like as I said, Keras. Keras the backend for performing the deep learning. So it is available in TensorFlow. If you install TensorFlow, this Keras is also will be installed. And then first I'll import, and I'm checking these two folders are available or not. So train and test. So these are the folders I'm checking. So I'm having in this folder, you can see train, test, and test data, right? So actually I'll rewrite. I have changed the code one. Okay. So So these are the folders. I'm checking like these folders are available or not. So I'll if I check, it will display what are the contents available in that folder. So it shows we do have multiple images like cat images and dog images. So using list directory, and then I'm these are the parameters I'm going to use. So my image should be in 128 in width it should be 128, as well as in height it should be 128. So I'm fixing all the parameters required. So and then, like as I said, as yesterday I have told you, right, there are three channels. One is RGB or so I have mentioning image channel as three. So I will use this all parameter in the model where so here this is where I'm creating the convolution layers. I'll cover one by one. So I'm just adding the required parameters. So I'm executing it. So and this, like where I'm running my code, is it is called Jupyter Notebook. It is also an interpreter, but like we can run cell by cell. So like because when I create a script, what happens is I need to rerun the script every time. But in case of Jupyter Notebook, I don't want to rerun all the script. I can run a certain part of the script. So that's why I'm preferring Jupyter Notebook instead of a Python script. So and then after declaring the parameters, so here I'm gonna read the images and convert into a data frame. So data frame is nothing. It's like Excel. You know Excel, right? Rows and columns. Likewise, in data frame also we do have rows and columns. I'm creating a data set, like a data frame, where it will return the return like this is the file name, and this is from which category. Like it's a dog or cat. So if it is a cat, it is 0, and if it is a dog, means it will be 1. So I'm reading now. Only I'm gonna read. I'll show you the steps. Print. So it's actually reading one by one and splitting the file name. So here I'm having the cat, right? So it will split where the dot is available, and then selecting the first part. So for example, um, so yeah, okay. So this is my list, means it will find dot split using dot, and I'm gonna select only zeroth index, means it will select only the cat. You, you can see, right? Likewise, it will read all the file names and find the label from the file name itself. So that is why we have named our images as a cat and dogs. So it's like it is not suggestible, but we can do like this also. That's what I'm telling. We can do in like whatever we need, but this is one of the way we can label the images. So in some examples, they will label the image in image itself. So they will draw a cube, and they will label in the image itself. But it is a simple way to label another, like labeling my image by naming the file itself as a label. So by iterating all the files, we are creating a data frame where it will return the file name and from which class it refers. So if I print df dot head, means it will give you the file name. This is from the cat, and it is categorized into 0. 0 means cat. If I print tail, so this is another label. You can see the difference. First, in cat it is categorized into 0, but in dog it is categorized into 1. So that means it differs, right? So dog means 1, cat means 0. So that is what I'm creating here. The df will hold all the values. So it is having around 24,781 values, 784 data. So from here, I'm gonna create a bar chart where it will show how many images, like how many data is available for cat and dog. So if you see 0 means cat is having 12,000 data. The same, the dog is also having the same 12,000 data. So from here, I'm gonna pick a random image from, like, because you can see here it is this now. While running, I have previously run it, so now it is displaying this image, right? When I run now, it will show a different image. It is showing dog image. So this is the actual image. What we are like, I'm displaying means I'm taking the actual image. That's I'm showing from train folder only. I'm picking this image. So I have taken the I'm shown the image, and then now we'll move to the part where we're gonna train our model. So I'm selecting, like, we are gonna do CNN. So we need to select a sequential model. So CNN comes in the sequential model. So we have imported all the required parameters from Keras.model. My model is sequential, and like as I said, like, deep learning consists of multiple layers, right? So input layer, convolutional layer, pooling layer. Likewise, there are flattened layer, dense layer, activation layer. So these are the layers I have told you before, like yesterday, right? So நான் இது சொன்னேன்ல, அதாவது டீப் லேர்னிங்னா ஒரு மல்டிபிள் லேயர்ஸ் கன்சிஸ்ட் ஆகி எல்லா லேயர்ஸ்லயும் ஒரு ஃபீச்சரா, லைக் வை வி ஆர் ஹேவிங் மல்டிபிள் லேயர்ஸ் இஸ் இட் it will create a feature map that will hold only the accurate features. So that is why we are having multiple layers. But in case of machine learning, we don't have this much layers. We just feed the data, it will train based on the data, and it will predict. But in case of deep learning, so that is why the name itself comes deep learning. So means it will learn the image deep. So we will pre-process the data so much accurate, and we will feed the data, the accurate data alone. So obviously it will impact the accuracy. So if I give accurate data, means it will train on the accurate data, and it will predict the accurate it's obviously it will affect the accuracy. The accuracy will be more while comparing to machine learning. That's why we are coming to deep learning. So we are importing all the required layers from Keras. So and then I'm adding all the layers into my model. So I have declared a model, and I'm adding the convolutional layer. So these are the deep parameters. So we'll learn on the 10 days class, but for now you just understand, we are adding a convolutional layer. So like the convolutional layer will be like, there are two types of convolution layer. One is ReLU and another one is available, but now we are using a ReLU layer. So here I'm feeding image with like inputs, like okay, I'll take the yesterday's example. So we'll compare the example, and we'll run. So yesterday I told you, right? So input layer will consist of three things. One is width, height, and channel. So that is what we have given here. Input shape, width, height, and channel. Channel is 3. So these parameters have been declared here in the first step. You can see, right? So these are the parameters I have used to create a input layer. So here only we are providing the inputs to the model. So this is the first step. We are adding the input. So and then after that we are normalizing. Like, have you heard the term normalization?
Yes, in database.
Yeah. So we are normalizing the data into a like into a like I can't explain the thing, but so we are normalizing the data. I'll tell you after the session. First, I'll finish up this thing. I'll tell you what is normalization. So we are normalizing the data, and then we are applying the max pooling, so that we will apply in the matrix and get the feature map. So likewise, we will add convolutional layer for the first time, and then second time we can add multiple convolutional layers. So here it is 32-bit, then 128, and then 120 like 64, 128, then 512. So but the convolutional layer is added 3 times. So after convolutional, we will max pool, and then again convolution, and then max pooling, again conversion, and again max pooling. After getting the finite feature map, we will flatten the data. So here, this is what happened in the convolution layer. So it will read the data, it will apply this matrix, and it will get the feature map. Likewise, we have done 3 times, and then like after convolutional, we are applying pooling. So and then again convolution, again pooling. So likewise, we have done 3 times, and then we are then flattening the data. So okay, I missed this step. Actually, we will flatten the data into a same dimension. So and then we will apply to the model. So this is how we will create a model. So I'll run it. So now it will start to run. Okay, so it is not running, but it is we are fixing all the technologies to run the model. So we have given all the parameters to run to train, but not yet it is trained. So we'll move forward. So I have imported callbacks from Kira's yearly stopping and reduce on plate. So yearly stopping will prevent overfitting the data. So overfitting is nothing but uh, I will I'm having a data, but if I'm having more than enough, like I just want 100 data, but if I'm having 200 or 300 data, means it won't throw an error, but it will train all 300 data. But actually what happened means, if I pass a test data, it will not get give the actual input actual output, but it will expect what actually available in the train data. It will accept like the same thing. For example, I'm okay, for example, this is my phone. So I'm having a phone. If my data is like this, like the phone, this is the image, means it will expect the same type of images in the test data also. It will not expect if I pass like this, it is also a phone, but it will not predict. If it slightly differs also, it can't able to predict, because it expects same type of data. So that is what we call it as a overfitting. So to avoid overfitting, we are using yearly stopping. So and then learning rate reduction. So this is where we will limit the model uh, to learn so till certain steps, until we get certain accuracy. If I get a certain accuracy, it will stop there itself. It will not allow to learn. So that is why we have imported these steps. I will pass this callback in my model in the next steps. Okay, and then so like in data frame, I'm changing zeros into cat and one into dog. So that is what I'm creating a new like not a new column, but the same column where it labeled as a 0, it is converted to cat, and one where it is 1, it is converted to dog. So now I'll print df. புரியுதா நான் என்ன சொல்றேன்? ஆக்சுவலா ரொம்ப ஸ்பீடா போறேன். புரியுதா நான் எப்படி போறேன்றதுல ஏதாவது டவுட்ஸ் இருக்கா?
Yes, you can continue in the space,
No,
Imran.
Imran, this is very clear only.
Okay, sure, yeah. So this is the step where we will allocate the data to the model. So we will not feed all the data. We will split the data into 2 parts, where it will consist of 80-20 shares. So the train data will be split into 2. One is for training alone, so it will have all the train data, and another one will have only test data. It is also like split into 4 types: X train, Y train, X test, Y test. So in X train, I will have all the features, and Y train means I will have the labels for the features for the X train, right? So it will have the labels. So one sec. So I'm having, if I'm having this cat and dog means, so this is feature, this is label. So it will split into 4 parts: X train, Y train. So in X train and Y train, I will have the, in X I will have the features or data, and this is Y means output. So if this is this my input means this will be my output. So this is X and this is Y. So it it will be split into four parts, where X will have the data alone, Y will have the output for this X train. So that is what we call it as a Y train. In X test, I will have the 20% data. So test size will be 20, right? So that means if I'm having 100 data means it will split into 80-20. 80 will be given to train parts and 20 will be given to test part. So here also I will have the X means data, Y means label. That means output. So, but in case of while getting the accuracy, it will just pass the X and it will not pass the Y, so that machine will give you the predictor outputs. Like we can say XP means XP. So then what we will do is we will compare this XP with Y test. So if it is written 0, 1, 1 means so I'll erase it one sec. So in case okay, 0, 0. In case 0, 0, 1, this is a predicted output, but actual output will have 0, 1, 1. So while comparing it, so these both are matching, right? So it is correct. These both are not matching, it is incorrect, and these both are matching, so it is correct. So out of 100 it gets like okay, I'll give another data. 1 means it is also correct. So out of 100 it out of 4 it answered 3 correctly. So my percentage will be 75. For example I have given, so 75% accuracy it got. So likewise we will split the data and we will pass to the to the model. So it will train and test itself, and then we can actually pass the actual real-time data. But these are the steps to get find the accuracy part. So we have allocated the data as a test size 0.20, means 20% data to the testing and 100 like 80% for training. So that is the step it is happening here. Now if I check like previously it is 12,000, right? If I check means it is 10,000. You can see, like, because the 2,000 data from each have been given to the test data. So that is why we are having a dog is 10,000 and cat is also having 10,000 data only. So now I'm okay. So it is validate df is okay. Okay, so this is the test data. Validate df means it is the test data. So in test data, I'm having around 2,500 images from each. So I think it is 9,500, 9,500 some okay, 10,000 and 2,500 data for from each class and given to the test data set. So this is validate is nothing but the test data. So and then I will reshape into a single point, so that total train data and total test data will be separated. So this will be given to model, and this will be given to validate the outcome. So now what I'm going to do is I will read the data. I will read the data and find how many classes available, and I will then only I will pass the train generator to the to my okay. Okay, so now I have created two datas. One is for training and another one is for testing. So this is the actual image. It consists of the actual image, and now if you see, so it is actually this is the only image. It is showing what are the possible ways for the images. So these are all these are all the same docs image. So in a different type views. So you can see the difference visually itself. You can see the difference. Like it is like this, and from left point how it looks. So if it is skipped into this like this means how it looks. Likewise, it will apply to the all outcomes to the model. So if I pass a image that is upside down also means it can able to find. So that is why it has been trained like this. Then now only I'm fitting the data to the model. So here is like previously I have created model. Now I'm fitting the data to my model. Okay, now it is started to train. So it actually it will take little time. So this is the estimated time to train the model. So it will train like this until it gets approaches I have given 50 approach. So if fast run else 50 approach. Okay, if fast run, okay, I have given fast run true or not. Okay, fast run true means it will run only one approach. Approach means nothing but how many times my model will train. So that is what we call it as a approach. Once yeah, one sec, I'll put the charge. Okay, so it started training. It will take a little time. So why we are like the parameter approach is nothing but the number of times it will train. So like if the approach is like, for example, if approach is 50 means it will train one by one, and it will get more accuracy. So if I'm having low approach means it will give a low accuracy, but due to time complexity I have used approach as a one, but it itself taking 20 minutes. But let's move on to the next step. So after it is training, but I can show you the sample output but not the actual output because it will take another 20 minutes, but I'll show you. So after training, what happened is we will save the model as a h5 or any format you want. We can save the model. So it will convert into binary files and it will be stored as a binary file. Why we are storing means if I want to predict another time, means I don't want to run all the models one by one until I because it for training one time itself it will take now I have given only one approach, but in case of if I give 200 approach, it will take half a day or 1 day or 2 days. So that much time it will take to train a model, because it should get a better accuracy, right? So we need to give a certain time for training. So so we have spent for example, we have spent 2 days, but if I want to predict another time, means I don't want to wait another 2 days. So instead of it, I will store the model in a file. So whenever I want, I can load the model and I can predict. So I don't want to train another time. So we are storing the model as a H5 format, and then so after training, it will okay, I need to run it. So actually after training only I can visually show you how much percentage of loss will be the loss in the accuracy. So out of 100, how many percentage loss, how many validation loss, training loss, validation loss is nothing but train data. It will pass to the test and it will give us a loss percentage, as well as it will pass a validation and it will give you the loss percentage, and the accuracy will be the positive thing. Positive thing means out of 100 how much marks I get. So it is how much marks I lose and how much marks I get. So that is what loss and accuracy. So okay. So here what I'm doing is like I'm passing the test data. So in test data I will not have the label. I just have the images. So that is what it is. Test 1, 2, 10, 100, 1000, like that. It is having the data. So I will read the data and I will pass that data to my actual model. So by converting to the image generator, because I need to give the, I can't directly pass the image as a image format, because as I said, like machine only understand the binary codes, but here we are actually having in a image, right? So we need to convert into the binary things. So for that I need to use the test gen or image generator. It will read the image and convert into a binary format. So that size, class mode, none means it will defaultly take the into a binary format, or if I want to convert it to different format also, means we can change to class mode. We can change the class mode, but we will give the default mode. So and then so here I will apply to the predict. Okay, so here only we will predict the outcome. So if it is like I can pass the test generator, so I have read the folder and convert into a test generator. Then I will pass the test generator to the model. So it will predict one by one and it will find the labels of the unknown image. Unknown image means these are all unknown because we don't have the labels, right? So if I pass this, means the model itself will find it is a dog or cat. So for that only we are passing the predict generator. So it will load the test folder. It will convert into image generator and it will be passed to the predict generator. So well, after passing it will be the outcome. We get the outcome and we will compare and we will find how many percentage accuracy we get. So it is saying we are having cat images 10,000, likewise it has been shown, and one means dog images like this. So okay, and then we are showing the images what we got. So this file will be generated as a final output. So it will have which are all dogs and which are all cats, the outcome of the trained model. So one is a one ID means the image name, file name. So one means this one. It is predicted as a dog. Actually, it is predicted as a cat. One sec, I'll check. 0 means dog or cat. Okay, 0 means cat and 1 means dog. So it is predicted wrongly because we have trained our approaches in a only one approach has been run, so it predicted wrongly. But in all cases, it is predicted wrongly. 3, it is predicted as a cat. 5 is also predicted as a cat. Cat. 27. So out of 1,000 or 10,000 data, it is predicted almost most of them are wrongly because we have trained our model only one approach. So automatically the accuracy will be affected because it didn't train well. So if I train well and if I pass into predict means we will get a better accuracy. So or else on our next session I'll show you the predicted outcome because I'll train my model into a 200 or 300 not 300, like 200 is enough, 200 approach, and then I'll show you the predicted outcome of the test case. So then we can actually see the actual outcome, because now it is not well trained. It is predicting wrongly. If I train well means it will definitely predict correctly. So do you have any doubts in this session? Any steps I have haven't explained well, or like do you have any doubts in certain part in test or train like that? If you have any doubts, you can ask me now.
Any doubts, guys?
Sorry, I have taken a lot of time, but it's a big concept, so it will take little time. Sorry for the issue.
Not a problem. Then. Any doubts, Makle? Irka, Ilya? Anything? No? Okay. Okay.
தியரியா கேட்கும்போது ஜாலியா இருந்திருக்கும், கோடா கேட்கும்போது கொஞ்சம் கஷ்டமா இருக்கும்.
ஆமா, டெஸ்டிங் மக்கள்லாம் கொஞ்சம் ஓடி போயிட்டாங்கதான்.
Actually,
what if
today's session, please continue.
இப்போ ஒரு கேட்டும் டாகும் ஒரே பிக்சர்ல இருந்தா என்ன ஆகும் அந்த மாதிரி சிச்சுவேஷன்ல?
அந்த மாதிரி சிச்சுவேஷன்ல எதோட ஃபீச்சர் எதோட நம்ம எப்படி எடுக்கிறோம்னா, மேக்ஸிமம் எந்த ஏஜஸ் வந்து ஷார்ப்பா இருக்கோ அதை தான் எடுக்கிறோம். ஸோ அதனால ஃபீச்சர் மேப்பே அப்ளை பண்றோம். ஸோ அப்போ எதோட இமேஜ் ரொம்ப கிளியரா இருக்கும் அதை தான் அது வந்து ஃபர்ஸ்ட் வந்து டிடெக்ட் பண்ணும். ஃபீச்சர்ஸ் பேஸ் பண்ணி தான் அதை டிடெக்ட் பண்ணும். ஸோ அதனால தான் நம்ம வந்து மேக்ஸ் பூலிங் அந்த கன்வல்யூஷன் திருப்பி அப்ளை பண்றோம். ஸோ அப்போ வந்து நமக்கு வந்து கிடைக்கிறதே ஒரு ஃபைனைட்டான அது. அப்போ இதோட இமேஜ் வந்து எந்த இமேஜ் கிளியரா இருக்கோ அப்போ அதோட தான் வந்து அதை தான் வந்து ஃபைண்ட் பண்ணும்.
ஓகே.
James sir?
Yes, Imran. Actually, for me, today's session is very interesting than yesterday. As a common man, we know as AI is very top level. For common man, AI is a magic actually. As a developer, we don't know how AI and all working. So I know internally it uses IoT, machine learning, deep learning, data science, all those things. Today's session, I can assume that how AI classifies the images by using the deep learning and all. So today's session definitely useful for me. Can you suggest any course for deep learning, machine learning? If you find, we can find many things, but
Sure.
as you know better than us, so can you suggest any courses, Udemy and any other thing?
Sure, I'll check and can I update you?
Sure.
Because for the moment I don't know, because like from after 2 years I have taken this topic. So because now I'm working in API development, but previously I have worked in machine learning. Now I myself itself outdated. So I'll recheck and I'll share you the which tutorial is better to learn for the beginner as well as I think by image search. Uh, have you heard about by image search? He will explain a little deep, and I think you can check the blog. So instead of purchasing, you can check the blog. Then you can purchase, because in blog itself he will explain little bit about the concepts. So after, if you understand, means you can go on purchase the course. He itself will introducing multiple courses. So first, please check his blog by image search.
Okay, okay, sure. Thank you, Imran.
Thank you, James. Yeah.